Ladies and gentlemen, you'll notice that last night I put in a ton of grades. Those ton of grades are pretty terrible in general. I think we have two A's across two classes. We have a bunch of D's and a bunch of E's and a few C's. You are clearly not paying attention during the videos. That's all there is to it. You're not watching the videos or you're not paying attention to them. And it's showing. Those quiz grades were the easiest part of this chapter. I had a 19. I had a 17. I think the next highest grade was a 13. So you're already at a failing grade. Your chapter test is supposed to be tomorrow and Friday. I'm pushing it back for you to get extra practice. Here's the other thing I'm going to do. I'm going to post videos of every single worksheet that we did. So your test is no longer Thursday and Friday. I'm going to give you two practice tests. Practice test Thursday, practice test Friday. I'm going to post videos of every single homework assignment from the chapter. Then you have the weekend to study. For those of you who need a math credit to graduate, good luck. If you've been struggling to this point, you really need to focus up this weekend. I'm still going to go over the study guide today because I want you to study from it. So you're going to take your study guide, your worksheets, and your practice tests and study over the weekend and come back Monday and Tuesday and try to pass this test. There are some of you who've not submitted an assignment in 3 weeks. It's ridiculous. If you think that you are not going to get a grade for this class, you're out of your mind. Because I'm not doing all this work for me. On your study guides, number 1, classified by its sides and angles. The 3 sides are all different. The angles are all different. That makes it a scalene. And this is a right. So it is a right scalene triangle. Number 2, equiangular, equilateral. Number 3, 2 sides are congruent, 2 of the angles are congruent. That is an isosceles, and the 120 makes it obtuse. So it's an obtuse isosceles triangle. Number 4, there's a theorem that says this exterior angle is equal to the sum of these 2 angles from inside the triangle. So you just set them equal to each other. 2x plus 30 equals 3x. Subtract 2x, you get x equals 30. Then ABD, ABD. Notice how an angle has 3 letters in it. This is from 2nd or 3rd week of school. If you're telling me that something's an angle, you can say angle B, but you can't say angle AB. That makes no sense. You get 0 points for that. AD is a line. See how it's a line and not an angle? Plug the 30 in. 3 times 30 is 90. So angle ABD equals 90 degrees. BDC equals 60 degrees. Find the measure of angles CAB and CBA. CAB, CBA. This is 90. We have 8x and x. All triangles add up to 180 degrees when you're talking about the angles. The side lengths don't add up to 180 degrees, just the angles. So 8x plus x plus 90 equals 180. It gives you 9x plus 90 equals 180. Subtract the 90. 9x equals 90. So x equals 10. Plug that in. 8 times 10 is 80. And this is 10. Done. It tells you these two triangles are congruent. Then it says find the value of x. You have 3x on DF. What does DF relate to? A and C. So AC is 9. So you have 3x equals 9. So x equals 3. Number 2. This is 22 degrees. It is angle A. It's the same as angle D. So 5y minus 3 equals 22. Add the 3 over. 5y equals 25. Divide by 5, y equals 5. Not hard. For your next section, in the diagram, ABCD is congruent to EFGH. Find the value of x. So you have to figure out what A is congruent to, or what E is congruent to. E and A are congruent to each other. AB is congruent to EF. Look at that. It's 8 equals 2x minus 6. Add the 6 over, you have 14 equals 2x. So x equals 7. And to find your y, 6y plus 4 equals 70. Subtract the 4 over, you get 6y equals 66. Divide by 6, y equals 11. Number 5, find the value of x. Well, this angle is congruent to this one, and this angle is congruent to this one. So now that's the third angles theorem. It says if this one is congruent to this, and this is congruent to this, then 65 is equal to x. Same thing here. This is congruent to this. This one is congruent to this angle. So 55 equals 5 times 3x plus 5. You can distribute that 5 right away. 15x plus 25. Subtract 25 over. You get 30 equals 15x. Divide by 15. X equals 2. Decide whether the congruent statement is true. Explain your reasoning. For this is what your quiz was like, and it was atrocious. You need to tell me why this is true. I know this side is congruent to this side. There's one side. I know this one is congruent to this side. Right? So we have a side and a side. The third side in both triangles is BD. That's automatically congruent to itself because it's the same thing. So your answer would just be side, side, side. You don't need to write anything else. Just write SSS for me. Look at number 2. We have 6 and 6, 9 and 9, And then the middle is 4 for both of them. I'm seeing a trend here. Side, congruent to that side. Side, congruent to that side. And side, congruent to this same side. Then do we have enough to say RST is congruent to VUT? Side, congruent to this side. Side, so RT is congruent to VT because they both have this one little mark. And side for TS or ST and UT. Side, side, side. Look at number 4. They share this side. It's congruent to itself. Any shared side is congruent to itself. Side, side, side. Number 5 is PQR congruent to RTS. So PQ is congruent to RT. I know that because they both have a single marking. Then QR is congruent to TS. And I know that because they both have a double marking. Then here, from S to V, and from V to R, there's this marking and another one. And then from P to T and T to R, there's the same marking and another one. So it's congruent by side, side, side. Number 6, this side is 6 for JK, and MP is 5. 6 does not equal 5, so it's no. Learn something new every day. Decide whether enough is given to prove that the triangles are congruent using SAS. We have PQ congruent to RQ. You can tell by the 2 little slashes. So I have a side. Then the angle Q here is congruent to this one. That's an angle. And then I have another side. So side, angle, side. Now, a lot of you were doing crazy stuff like, oh, it's, I don't even know what you were coming up with. But it was like nuts. It's got to be the angle that's in between these two. See how the angle is in between the 2 that are congruent? This one and this one? That's what makes it side, angle, side. Okay. Number 2, this angle is congruent to this one because they're vertical angles. Now I have side, angle, side. Done. Number 3, XY is congruent to itself. So now I have side, angle, side. This one's tricky because if you look over here, I have side, angle, but I don't have the third side. I have the third side way over here. That's not attached to the angle. So that would be no. Alright, now we're going to write a proof for 4 and 5. So, on the left side, would be statements, right side reasons. All right, number one statement. AB is congruent to DB. How do we know that? It's given to us. Also, let's do BC perpendicular to AD, because that's also given. Step 2. Then I know ACB, angle ACB, and DCB are right angles. The reason I know that is definition of perpendicular. So then I know ACB is congruent to DCB. Reason for that, right angles are congruent. Or you could say definition of right angles. That's fine too. Step 4, BC is congruent to BC by the reflexive property. So now I've showed this is congruent to this. That's congruent to itself. Huh. We didn't even need all that. Yeah, we did. We just didn't need step 3, technically. Because this hypotenuse leg. Hypotenuse is congruent to this hypotenuse. The legs are congruent, and you have a 90 degree. So that would be hypotenuse leg. So then you would say triangle ABC is congruent to triangle DBC, and the reason is hypotenuse leg. That was fun. Next one. Got statements, reasons. JKL is equal to MLK. Which is equal to 90. That's given. And then JL is congruent to MK is also given. Then for step 2, so we have this hypotenuse congruent to this hypotenuse. That one congruent to that one. So now we have to prove that one of the legs is congruent to one of these legs. And we know that. KL is congruent to KL. So reflexive. In step 3, triangle JKL is congruent to triangle MLK. And the reason for that is, hypotenuse leg. Can the triangles be proven congruent with the information given in the diagram? If so, state the postulate. Write the error you would use. We don't have any sides in this. There's no angle, angle. So that's no. This one, we have an angle on the side, and then we have the vertical angles in here. It gives you angle, side, angle. The side is directly in between the two angles. This one, we have an angle, a side, in that order. And we also have angle, side. See how the side doesn't split them up or anything? That makes it A, S, angle, side. Okay, number 4. Given that the angle PQS is congruent to RQS and QSP, is congruent to QSR, see if you can prove that those two are congruent. Statements and reasons. First statement, the angle PQS is congruent to angle RQS, and angle QSP is congruent to angle QSR, and the reason for that is given. So if this angle congruent to this one, and this one congruent to this one. Excuse me. So we have an angle and an angle. Then in the middle you have QS congruent to itself by the reflexive property. QS congruent to QS. And that's reflexive. So basically you have angle, side, angle. And that's all you need. Triangle PQS is congruent to triangle RQS. And the reason is angle, side, angle. Next one, OMN is congruent to angle ONM. And angle LMO is congruent to angle JNO. And that is given. Now we have to prove that triangle MJN is congruent to triangle NLM. So we know that this angle is congruent to this one. And then this little angle here is congruent to that one there. We also are going to know that NM is congruent to itself. So I'm going to do that right now. See how it's in a lot of questions. Look to see if a side is shared amongst both triangles every time. Reflexive. So I have a side and an angle, but this big angle we don't know yet. But we actually are going to know that. We can say MNJ is equal to MNL plus ONJ, and we can say NML is equal to NMO plus OML. That's by the angle addition postulate. So basically, if you're looking at this, you have this angle. I'm going to zoom in. You have this angle plus this angle makes up this whole big angle here. You see this piece is the same as this piece, and this piece is the same as this piece. So then those two added together make up this whole big angle here. And that's using angle addition postulate. Then for step 4, you can say angle M and J is congruent to angle N M L. That would either be transitive or substitution. So now if I'm looking at the diagram, I have angle, side, and a big angle. So I have angle, side, angle. So I can then say that triangle MJN is congruent to triangle NLM, and the reason is angle, side, angle. Okay, tell which triangles you can show are congruent in order to prove this statement. What postulate or theorem would you use? So if you're trying to prove that JK is congruent to LK, and you need to prove that this triangle is congruent to this one first. So it would be triangle JKM is congruent to triangle LKM. And how would you prove it? They share a side, MK, so it would be reflexive. So we know that this is then side, angle, side. Alright, you need to prove that RPQ is congruent to TRS. So how would we prove that? Well, we have to prove that triangle RPQ is congruent to triangle TRS. And so when we look at how we would prove that, we know that this is parallel to this, and this is the transversal that cuts it, right? So we have an angle congruent to an angle. Then because the transversal cuts these parallel lines, these are corresponding angles. So you would use corresponding angles, and then it would be angle, angle, side. That's it. Use the diagram and the given information, write a plan for a proof. AB is congruent to EB. That's given. FB is congruent to CB. Also given. And you need to prove that BG is congruent to BD. It's a lot harder than it looks, I'll give you that. So we have this congruent to this, and this congruent to this. And then in the middle, you're going to have vertical angles. Right? And so, well, we don't even have to do the whole thing. We're going to have to show that this whole angle is congruent to this whole angle to get side angle side. And then once we know that, so we can say angle ABF is congruent to angle EBF. And that's because those are vertical angles. And we know that the big triangles are congruent. So we can say triangle ABF is congruent to triangle CBE. And that's by side angle side. Then once we know that, we can break this big angle down. For the record, you're not going to have one this bad on your test at all. You can break that down. Say angle ABG is congruent to angle EBD. That's the same reason for vertical angles. Then we know from CPCTC, that AG is congruent to ED. No, that doesn't work. Well, we can tell, I was looking at BG and BD. So it'd be BG is congruent to BD by CPCTC. Number 4, we are not even going to worry about. It's going to be a complicated one, overcomplicated for what our purposes are. Use the information in the diagram to find the given values. Find WY. So, because this is an isosceles triangle, this has to be 6. Then find the measure of angle WXY. It has to be 60 because that is an equilateral triangle. Find the values of X and Y in the diagram at the right. Alright, so we gotta find the values of X and Y. Oh, this sucks. So this is 12. Then this whole thing is a straight line. This is 60 degrees. This is 90 degrees. So there's a little piece in the middle. It would be 180 minus 90 minus 60 to give you 30. And this triangle, these angle measurements have to be the same. This one and this one. And so 30 plus 2x equals 180. Subtract 30 over, you get 2x equals 150. So x equals 75. Then this piece has to be congruent to this piece, which has to be congruent to that piece because of their markings. Now we can use Pythagorean theorem to find this little piece here. Because y is this whole stretch. We already know that this piece is 12. So you do 12 squared plus x squared equals 15 squared. 144 plus x squared equals 225. Subtract 144 from 225. Gives you 81. Square root of that is 9. So this little section here is going to be 9. And 9 plus 12 gives you that y is 21. Then it says an example 4 above. We don't have an example 4 above, so can't do this question. How bad. Name the type of transformation shown. This is a reflection. Number 2 and 3 didn't give you a lot of space to write these all out. But if we're translating it x plus 6, y minus 2, and 8 prime, you literally just add 6 to negative 5. Gives you a positive 1. 5 minus 2 is 3. b prime, negative 1 plus 6 is 5, negative 2, 2 minus 2 is 0, c prime will be negative 3 plus 6, which is 3, and 0 minus 2, which is negative 2, d prime, negative 5 plus 6, which is 1, and 0 minus 2, which is negative 2. So that would be your answer. For number 3, if it's a reflection in the x-axis, means your y's also, or your x's all stay exactly the same. All it changes is your y's. So for number 3, a prime would be negative 5, and it just makes this negative. Negative 5. B prime would be negative 1 and negative 2. C prime, negative 3 and 0. Can't make 0 negative, stays the same. And D prime is negative 5, 0. Lastly, tell whether CD is a rotation of AB about the origin. That would be picking this up and rotating it by 90 degrees. So B would move to where D is, and AB, if it's rotating 90 degrees, if it goes over 1 and up 2, it's now going to go up 1 and over 2. And so that would be yes. And it's a rotation 90 degrees counterclockwise. Number 5. This would be rotating at 180 degrees. So it would be like picking this image up. That's going to look good. It would be like picking this image up and spinning it 180 degrees around the origin. So it would look very similar to that. And BA now is not lined up with DC. So that one would be a no. Basically, if you're looking at spinning at 180 degrees around the origin, I believe we take these values and make them both the opposite side. This one, we also have to flip the order of them too. So this would be 1, negative 1. And this would be 4, negative 2. To come up here, it's going to be negative 1, 1, which is good. But then it's also going to be -4, +2. Put it there. And it's not, so that's why it's a big no. Okay, practice test tomorrow. Practice test Friday. Give some effort on these.